Hello students, welcome back. Let us start with a new chapter of algebra, that is Heron's formula. This is going to be based on areas of triangle. This is chapter 12 and the topics to be covered are introduction, area of triangle using Heron's formula, application of Heron's formula in finding the area of quadrilaterals, and summary. So this is Heron apostrophe S. So now you must be wondering why are we looking at this formula for finding the area of the triangle, because we have already learned that the area of triangle is what? Area of triangle, we have seen that it is half into base into height. So let us understand these two terms, base and height. So if I give you a triangle ABC, I would say BC is the base and AB is the height if this is the ground. So what does height mean? Height is the perpendicular drawn from one point to the base. So this thing has to always be perpendicular, which means we can apply this formula, area of a triangle is equal to half into base into height, if and only if we have something perpendicular. So let's say the different kind of triangles that we have. We have a right angled triangle, then we have equilateral triangle, we have isosceles triangle, and finally we have scalene triangle. So in right angle triangle like this, if I give you the base, let's say 5 centimeters and say the height 8 centimeters, you can easily apply this formula, area of triangle is equal to half into base into height, which is half into 5 into 8, right? So this would be 2 1s are 2, 2 4s are 8, so area is 20 units square. How about an equilateral triangle where one side is given? So let's say I have an equilateral triangle PQR. What do we know for an equilateral triangle? That each side is equal. So let's say one side is 6 centimeters, so obviously each of these sides is going to be 6 centimeters. If I take QR as the base and point P as the vertex and I draw a perpendicular over here, what do you know about the perpendicular drawn from one vertex to the opposite side in an equilateral triangle? That it is also the median of the triangle, which means this point here, suppose this is 6 centimeters out, this point O. So PO is perpendicular to OR and PO is also the median of this triangle. That means O is the midpoint of QR. So QO is going to be 3 centimeters, that is half of QR because O is the midpoint, and PO, just one moment. So you have QO as 3 centimeters and you have this side PQ is equal to 6 centimeters. Using Pythagoras theorem, you can find the side PO. So how would you find side PO? You're going to use hypotenuse formula wherein, so using Pythagoras theorem, you will get PQ square is equal to PO square plus QO square, right? What do we need to find out? We need to find PO. So this would be, therefore PO square is going to be PQ square minus QO square, right? So PQ square will be 6 square, which is 36, and this would be 3 square, which is 9. So 36 minus 9, 27. So PO square is 27. Therefore, PO will be what? It will be under root of 27, which is 3 root 3, right? How did I find the under root of 27? So if this is 27 out here, 3 9s are 27 and 9 1s are 9. So 27 can be written as 9 into 3. Now the square root of 9 is what? 3, and the square root of 3 is 3. So 3 root 3 is PQ. So is PO. So I found the height PO and I have the base QR. Can I find the area of my triangle? Yes. How will I find it? Half into base, which is 6, the entire base, into height, which is 3 root 3. Right? So 2 ones are 2, 2 threes are 6. So 9 root 3 square units is the area of my equilateral triangle. How about an isosceles triangle? So if I have my isosceles triangle where I have been given the length of the common side, any one side, and the length of the other side, can I find the area of my triangle? So let's say I have my isosceles triangle XYZ, wherein side XY is equal to XZ, and it's been given that, let's say, this side, the equal sides are 6 centimeters and this side YZ is 8 centimeters. If I draw a perpendicular from X to YZ, if you notice, this side is equal to this side. So can we call them the radii of any circle? Yes, we can. So let's say this is our circle with center X. So XY is equal to XZ, which are the radii of the circle, and XO is the perpendicular drawn from the center of the circle to the chord. Now the perpendicular drawn from the center of the circle to the chord bisects the chord. So YO is equal to OZ, right? So here again you will find the length of YO, which is going to be half of YZ, which is 4 centimeters. Then you have the length XZ, which is 6 centimeters. Using Pythagoras theorem, you can find this length. Once you find this length, you have the height and you have the base. You can find the area of your triangle. So now this was about an isosceles triangle. How about area of a scalene triangle wherein you've been given the length of all the sides? So let's say I have a scalene triangle MNP, where I have 3 centimeters, 8 centimeters and 10 centimeters. How do I find the area of the triangle? Even if I take a height from M to the base NP, it won't really be possible for me to find this height, even though I have the base. See, how do I find the height when only this side is being given? I have no idea about this side. In cases like these, for scalene triangle where it is not really possible to find the height and thereby the area of the triangle, you are going to refer to what is known as the HERON'S formula. So now let's take a look at HERON'S formula. So first of all, this formula is named after the mathematician himself who came up with the formula. So this is given by area of triangle is equal to under root of S into S minus A into S minus B into S minus C. So you must be wondering what is S and what is ABC. It means nothing but if I have a triangle ABC, we know that the side opposite the vertex is named by the lowercase letter of the vertex. So this would be A, this would be B, and this side would be C, right? So A is side 1, B is side 2 and C is side 3. Then what is S? S is the semi-perimeter of the triangle. So first of all, what is perimeter? If let's say if there is a triangular ground, okay, and I want to walk through this entire ground. So what is the perimeter going to be? If I start from point A, I walk through point B, then from B to C, and then finally from C to A, and I reach point A again, covering this entire path of triangle ABC or the triangular path ABC, I am said to have covered the perimeter. So perimeter is nothing but the sum of all sides of the given figure. So semi-perimeter would be what? First of all, perimeter is what? A plus B plus C, right? Because side A plus side B plus side C. So the semi-perimeter is given by, semi means half. So semi-perimeter would be half of the perimeter, which is P by 2, which is nothing but A plus B plus C by 2. So what is Heron's formula? Heron's formula helps you find the area of triangle, which is given by under root of S into S minus A into S minus B into S minus C, where S is the semi-perimeter of the triangle and A, B and C are the sides of your given triangle. So this was about the introduction of what exactly Heron's formula is all about. We'll take a look at few solved examples in the next videos. Thank you.
Hope this video increased your knowledge. For more such videos and a completely free educational content, log on to www.epathshala.org or visit our ePathshala YouTube channel. We have each and every question solved for maths, physics, chemistry and biology. So subscribe our channel, share with your friends, like our Facebook page and follow our Twitter handle for regular updates and important educational tips, and also win ePathshala goodies. So what are you waiting for? Subscribe this channel and enjoy the freedom of education.